So this is just more practice. This is not the actual practice final. The actual practice final is 32 questions long. There's 4 videos explaining each side of it. It's 2 pages, actually 4 pages. 2 pages that are 2-sided, so it's a total of 4 pages. And those videos are already made. I would go back and study all those because those 32 questions on the practice final are identical, not identical, but very similar to the 32 questions on the actual final that you're taking for you guys the day after tomorrow, for some others tomorrow. So number 1, this is just extra questions, reviewing extra. So number 1, it says to write the algebraic expression of this sentence 5 times. So that's 5 times. You could put a dot if you want. You don't have to. 5 times what? 5 times x squared. So that's really 5x squared. Minus, that's a minus sign, 7 times x. That's just 7x. And that's it, guys. That's the answer to number 1 on this video that I'm doing. All easy. Number 2, it says state the domain of the relation. So we have a bunch of coordinates here. If I actually write these coordinates, this coordinate right here is -4, -4. This coordinate right here is -2, 0. This coordinate down here is 0, -5. This coordinate up here is 1, 2. This coordinate right here is 2, -2. And this coordinate right here is 4 and 1/2, or 0.5. So those are all the coordinates listed perfectly. Now we know, or we should know, that the word domain means x values, the input values, the range, or the y values, the output values. So we really have all of these guys that are x's, and over here are the y's, but they're asking for the domain, so we're going to list the domain. On the multiple choice, it's going to look like this. D, if they ask for domain, they might ask for range. They're going to have those funky brackets, the x. They're going to put the list of numbers -4, -2, 0, 1, 2, 4. So that's how the answer is going to be on the final tomorrow, or day after tomorrow for you guys. Moving on to the next one on this video. In 2001, Musicland sold 18,075 CDs. In 2010, Musicland sold 1,200 CDs. That makes sense because CDs were a lot more popular back in the early 2000s. And as time goes by, CDs become less popular. Right now, they're obsolete in reality.
More like collector's items.
Yeah, more like collector's items. So, what we need to know for this problem is this phrase, rate of change. And rate of change, I should probably underline it in blue, rate of change is slope. So for slope, we're going to use the slope formula. y2 minus y1 over x2 minus x1. The problem is we need some coordinates to be able to use the slope formula. So we actually do have some input and output values. What do I mean by that? Well, in 2001, that's like an input. The output is how many CDs they sold. So that's one coordinate, 2001 and 18,075. And another coordinate is 2010 and 1,200 CDs were sold in 2010. So when we plug it in, let's label them X, Y, X, Y, first point, second point. So Y2 is 1,200, Y1, 18,075, X2 is 2010, X1 is 2001, 2001. And when we subtract, on the bottom it's pretty easy, that's 9. On the top, negative 16,875, and of course that's with the calculator. So when you divide negative 16,875 by 9, we get, yeah, negative, there's a negative right there, 1,875. So what does negative 1,875 mean? That the amount of CDs sold each year was decreased by, so 1,875 per year. Per year. I don't know why I put a dot right there. But yeah, per year. That's the answer to number 3. Very similar question like that one on the test tomorrow. Number 4, does f of x represent the table indicated below? What do you guys say? So if you're thinking right here, this is a function machine, and XY table is really an input-output table. So if I take the 5, put it right here, negative 3 times 5, that's negative 10 plus, or negative 15, plus 5, that's negative 10. Plug in 4 right there. Negative 3 times 4 is negative 12, plus 5, it is negative 7. So you're probably thinking that this does work. However, if I plug in 2 right here, what's negative 3 times 2? Negative 6. And what's negative 6 plus 5? Negative 1, not positive 1. It's negative 1. So technically, this guy right here is messing it up, and the function does not represent that entire XY table. Okay, now, obviously tomorrow, or not tomorrow, when you guys take the final, it's going to be a multiple choice test. So they're going to give you an XY table, and they're going to give you a bunch of different functions. One option is to actually start plugging in x, see if you get out y. Plug in x, see if you get out y. And if it works for all of them, then that's the function you want. Another way of doing it is, well, this one right here, like let's say for the final, it will have a common difference. Like right here, it doesn't have a common difference. But if this were a negative 1, let's pretend just for a second that it's a negative 1. That way we will have a common difference. From 2 to negative 1, it goes down by 3. From negative 1 to negative 4, it goes down by 3. From negative 4 to negative 7, it goes down by 3. And so on and so on. Does that make sense? Yeah. So our common difference is negative 3 if, that's hypothetical, if that were a negative 1. So what you could do there is, because we have consecutive inputs, 1, 2, 3, 4, 5, then technically our first number, a sub 1, is 2. Right? And you could actually use the a sub nth rule, which is a sub 1 plus n minus 1 times a common difference d, and then you could plug it in, distribute, simplify, and get your y equals mx plus b equation, which you'll find on your multiple choice. So there's many, many ways of doing this problem, okay? One is to take your xy table that they give you and simply plug in the input, see if it gives you the output by doing the math. And you do that for all of them. And once it doesn't work, you move on to the next f of x function and see if you could find it that way. Or you could recognize if it's linear, and if it is linear, you could use the a sub nth rule, or you could even say, well, it is linear because there's a common difference. I'm going to use this coordinate and this coordinate to find the slope, and then I could use any x and y value to plug it into y equals mx plus b to solve for b. So there's many, many different ways of doing it. The easiest, most straightforward way, I think, is to just plug in the inputs and check to see if it actually gives you the outputs. It's up to you guys, though. I'm not going to explain all the different methods. I mean, I kind of did, but I'm not going to actually work it out. So in this case, it was not the function. Why not? Because the input of 2 did not give us the output of 1. How about graphing that guy? Is that in slope-intercept form?
Yes, it is.
Yes, it is. So right here, the m value is negative 2/3, and the b value is 0. So it does cross at 0. And from that point, am I going to go up 2 or down 2? Down 2 over 1, 2, 3. Put a dot right there. Connect the dots. You're done.
No, you're not.
Yes, you're done.
Don't you have to do the little weird squiggly one?
That's on inequalities. Let's check out number 6 up here. So on tomorrow's final, Thursday for you guys, there's going to be a graph. You're going to have to know how to interpret it, right? So let's just talk about this graph, and let me ask you some things. Is there any point where the rainfall remains consistent, like it's a steady rainfall? Like, no, right? It's raining, it starts sprinkling. And then all of a sudden it rains a lot, but then it all of a sudden starts dropping the amount of rain to a regular rainfall. And then another downpour, and then it goes back down to sprinkling, right? If, let's say this were the y-axis right here, yeah? what could he tell me about the y-axis? When did we start recording? At 1 p.m. and at about how many milliliters? 5 milliliters, right? Okay. So it's good that we know how to interpret graphs. Number 7, oh, this is a good one. Is the above graph a function or just a relation? Function. Because if you do the vertical line test, you're never going to have 2 points crossing that vertical line. So if I just draw a vertical line, it crosses there, draw a vertical line, crosses there, vertical line. So it never crosses at 2 points, right? So it is a function. It passes the vertical line test. Let's just, side note here, is that a function? No, that's a relation, right? How about, is that a function? Yes, it passes the vertical line test. How about if I had something like, let's say something like this, some stair action.
No, because it's not even. Wait.
Is it a function?
No, because there's straight lines going like that.
Yeah, if you do a vertical line, guys, it has a lot of points in common. So that fails the vertical line test also. Okay? Keep that in mind. It will pop up on the final. Number 8. You want to get rid of the fractions? Let's multiply both sides by what? 7 times 7 cancels. Negative 4k equals negative. So you have negative 4k equals negative 112. Let's divide both sides by negative 4, and you will get k equals positive 28. Number 9, if a circle is drawn on an xy coordinate plane, can that graph be a function or just a relation?
A relation.
Relation, that's right.
Because it's an x.
So that's a relation. Okay, number 10, write the inequality of the graph shown. Okay, this is a little bit more confusing. It's hard to see, but this has a certain shading, has a shading on this side, okay? So we need to come up with the equation that or not the equation, the inequality that actually produces this shaded graph. So first of all, we have a line, and in order for us to come up with an equation of a line, y equals mx plus b, we need 2 things. What are they? Your slope and your y-intercept, the m and the b. So can we find the m just by looking at that line? Yeah. What is the m? See, you need to pick 2 points that are nice. Now, what do I mean by that? Check this out, guys. This is a nice point, right? So how about this? Let's put a nice point right here. But is this a nice point?
No.
Is that a nice point?
No.
Is this a nice point? Yes. So you put your dot up there, you put your dot down there. Now you could say, okay, from left to right, am I going up or am I going down? Going down. How many? 1, 2, 3 over 1. So the slope is down 3 over 1. So the slope's just negative 3. Got that, Adrian?
Yeah.
Okay, so now let's go for the b value. Now, what is the b value? Negative 2. The definition of the b value is the y-intercept. Here's the y. The line crosses right here at negative 2. So that's all there is to it. B is negative 2. So once you know the m, once you know the b, you could write your slope-intercept form equation. Y equals, but remember, this is not equals, this is an inequality. I'll leave it blank. Y, blank spot, mx plus b, negative 3x plus b is negative 2. So first of all, you see how this line's solid? So you're going to have a solid line underneath your inequality. So I might as well put that solid line underneath the inequality. Now the question is it going to be like that or is it going to be like that? The less than or the greater than? Here's one trick. Do we shade in above the solid line or below the solid line? Below. So that would be less than, right? So less than or equal to, that's your inequality that produces that graph right there with the shaded area. Now let's say you weren't too sure about it. If you want, you could test the point. Like you could test 0, 0, which is clearly on the wrong side, so it should not work. So if I do plug in a 0 for y and a 0 for x, it will say 0 is less than or equal to -2. Is that true or false? 0 is definitely not less than -2. It's not equal to -2. So yeah, it's false. We already knew that. It's not on that side. The answers are on this side. So we know we have the right inequality right here. Let's move on. Number 11. Write the point-slope form of the equation of the line passing through the given point and is parallel to the graph of the given equation. So they give us a coordinate. They want us to write the slope-intercept form equation. Slope-intercept form is y equals mx plus b. And they do give us an x value and a y value, and they also give us this, this equation. Now they're telling us that our equation is going to be parallel, which means same slope. So we could clearly see the slope of this equation, which is -6. So that means that our slope, because it's parallel, will also be -6. So what do we have here, guys? We have a point and we have a slope. You could use point-slope form and then change it to slope-intercept, because that's what they want. They say write it in slope-intercept form. But so you could use the point and the slope to write your point-slope form equation, then change it to slope-intercept, or you could just take your x value, plug it right into your x, take your y value, plug it right into your y, take your m value, plug it right into m. That way you could solve for b. And I think that's the quickest way of doing it. So let's do that. I'm going to take this x value of -4 and plug it right there where the x value is at. So I'm going to have a -4 in place of x. Now the m, I'm going to take the m of -6 and put it right there where the m spot is. And that's going to be a -6 being multiplied by the -4. And then I have the equals and also the y value. The y value is -5. I'm going to plug in that y value right there where the y goes. So that's going to be a -5 on the y spot. And of course we still have the plus b over here. So we plugged in the y, the m, and the x, and now we could actually solve for b. So when we solve for b, we have -6 times -4. That is positive 24. Plus b equals -5. And then we subtract 24, and we will get your b value being -29 equals b. b equals -29. Is that right? Okay, so we really have a m value and a b value. Now we could actually write our slope-intercept form equation, which is y equals mx plus b. So we have y equals m -6 x plus b, which is -29. Okay, so the next one, 12, it's a little bit more fun. It says write the slope-intercept form equation of the line passing through the given point and is, you know what? On this one, ladies and gentlemen, let's switch it. Since we already did one with parallel, let's change this parallel to perpendicular. Okay, so they give us an equation right here, and this is in standard form, ax plus by equals c, all capital A, B, and C. But notice that there is no m in standard form, so you cannot see the slope. So what you would have to do is change the standard form into slope-intercept form so you could actually see the slope. So let's first get rid of that -2x by doing plus 2x, and now you'll have y equals 2x minus 7, and that is slope-intercept form, and now you could actually see the slope of that slope-intercept form equation. So this equation that was originally in standard, I changed it to slope-intercept. Why? Only to see that m equals 2. Bless you, bless you. Now that I know that their slope is 2, my slope needs to be perpendicular to it. Now,
You have to flip it and you have to change the sign.
you have to flip it and change the sign. So
-1/2.
put the 1 underneath the 2, flip it and change the sign. It's going to be -1/2. Now after that, you have your slope and you have a coordinate xy. So you could plug it all into y equals mx plus b again. Y equals mx plus b. your y value is negative 1 equals the m value is negative half times x. X is negative 3 plus b. Plus b. So when we multiply 1/2 times negative 3, you can put the negative 3 over a 1, then simply multiply negative 1 times negative 3 and get a positive 3, and then 2 times 1 and get a 2. So your new fraction will be positive 3/2 plus b equals negative 1. Now, at this point, you could deal with the fraction 3/2. 3 divided by 2 is really 1.5. And then you could subtract 1.5, and that'll give you a negative 2.5 value of b. But if it confuses you, you could multiply everything by the fraction, by the denominator of the fraction, which is 2. So go times 2, times 2, times 2. You'll get negative 2 equals 3 plus 2b. And then you could subtract 3. You'll have negative 5 equals 2b. So for your final step, you divide by 2. b equals negative 5/2, or negative 2.5. But the point is, we found m because it's the perpendicular slope of what we originally had on the original equation, which you change the sign and flip it. And then we have the new b value that we found by plugging in y, x, and m and solving for b. So now we can write our slope-intercept form equation. Y equals negative 1/2 x plus b, which is minus 5/2. And that is your equation in slope-intercept form. So obviously there's more than 12 questions on the final exam. Like I said, I gave you a practice final that had 32 questions on it. There's 4 videos explaining those 32 questions. The final exam is 32 questions. We only have 12 right here that come out on the final, so I highly recommend you go back and watch all 32 questions on those 4 videos that we posted last week. I'm out.